All right, question number 8. We want to write a polynomial that satisfies the given condition, so degree 3. So that tells us 3 zeros max, and then it says with integer coefficients, so we want whole number coefficients in front, and we have zeros of 5i and 6 divided by 5. Okay, so we want to write a polynomial of the form x to the third plus whatever else comes after that. It gives us that we have some zeros, so it gives us x equals 5i. Okay. And in the previous problem and in the text, it tells you that if you have an imaginary term and you have a positive, you also have the negative of that term. So we also get for free another zero is negative 5i. And then it tells us the other zero is x equals 6 divided by 5. All right, so in order to write our polynomial, we need to write these 3 zeros in linear form, set them equal to 0 basically, and we're going to multiply them together. So I'm going to multiply by 5. Multiply by 5 to get rid of division. And this gives me 5x equals 6. And then if we subtract and move the 6 over, for this term, we will get 5x minus 6. And that's equal to 0, but this is the linear term that we need. And then for each of these, we just move the term over. So for this top term, we would have to subtract. And then for the bottom term, we'd have to add it, so we would get x plus 5i. All right, so this is your start. When we multiply this together, this will give us our degree 3. Now, sometimes you might have an ordered pair that they want this polynomial to go through. If that's the case, normally we would put an a out here, okay? And then we have y equal. Okay, so some of that's running off. If you wanted to figure out what this a value was, you would plug in an ordered pair. Let's just say I wanted this to go through 2, 6. Okay, I will plug 2 for x and 6 for y and solve for a. But in this case, we don't have an ordered pair. However, I'm going to multiply this out and get an x to the third. Difference of squares here, so I'm going to multiply these two together first. It's going to give me x squared minus this term squared. Okay, so I'm just going to leave that alone. This is going to give me x squared minus 5i squared. Now, this whole thing is squared. Square 5, we get 25. Square I, we get I squared. So this, just working on the second part, x squared minus 25 I squared. Recall I squared is -1, so negative times a negative, this becomes a positive 25. And so now I just need to multiply 5x minus 6 times x squared, now plus 25. All right. 5x times x squared, 5x cubed, and then negative 6 times x squared. All right, then 5x times 25, positive 125x, and then negative 6 times 25. Okay, so this is the basic form of a polynomial with the given zeros. Now, if we wanted, again, we could make it go through a specific point. We can multiply this by any number, but it has integer coefficients, whole numbers here, and we have a degree 3.